Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about why it really pays to spend a bit of time on fine-tuning the lid you want to use in your hydrodynamics analysis in the ProteusDS SHIBMO 3D toolset. So to highlight all of this, I want to use this 35-meter hull sample project here. So notably, it's got a little bit of a bulbous bow here, and that's usually sometimes where something can cause problems when you're trying to work with a lid. But let's talk about like what's going on here. The two things I want to talk about and why it's worth spending time fine-tuning the lid is it doesn't take that long to do the fine-tuning process, and the payback is that if you do it right and you spend a little bit of time on it, you get much higher quality hydrodynamics results out of it. And the other thing is that it's well worth spending a little bit of time on working with a lid because there's actually a big consequence for using a lid in much slower hydrodynamics calculations. So we'll talk about that with a specific example here. Now, in this project, I have loaded up, what does the hydrodynamic analysis look like, the radiation and diffraction on this hull without any lid at all. So the first thing I want to just highlight is in the output here, the total computation time. I mean, this is a pretty coarse mesh. There's not that many panels in it, so it takes, about 500 seconds, actually pretty fast, for in the grand scheme of things for this kind of analysis. Let's take a look at the results. So if we plot the radiation and diffraction coefficients, well, they're not that great. This is normal to see little bumps like this, little spikes. These are signs of irregular frequencies. So what we're looking at here are the added mass and damping curves, the wave radiation effects on this hull for different frequencies, for surge, sway, heave, roll, pitch, and yaw. And then these are the two numerical conditioning numbers. So these are purely numericals. It's just letting you know when there are chances of having these so-called irregular frequencies, these cases where the numerical solution is breaking down a little bit. So, it's not the end of the world. You probably could use this data if you didn't have any other choice, but it's not my own preference. If you can avoid it, and if you can clean up the data a little bit, so much the better. And that's where the lid method comes in. So these irregular frequencies, oftentimes they're kind of caused by things like artificial wave effects showing up inside the ship hull, which is obviously not something that happens in reality. When you're doing the wave radiation analysis, the hull is moving around. You want it to be pushing the water around. You don't want anything showing up inside the hull as part of the numerical solution process. And this is where the lid comes in. So we'll close that. Close this one here. So now here's where the tricky thing comes in. Let's add a new data, and we'll do the default settings for the lid method. So one of the inputs is the wet panel hull file. So the default setting here, wet hull waterline, it tries to sort of fit a lid through non-dimensional kind of dimensions inside the waterline sort of circumference of the hull, and usually works pretty well. In this case, actually, it does work okay here. If we plot panel lid, what you want to see is lots of pink on the inside area and covering as much as possible. And so you can see there's a little gap here just based on the default non-dimensionalization parameters. What I've found is when you have really funky bulbous bows or other kind of strange geometry, it can have a hard time fitting in the lid. If you're having a hard time fitting in the lid, usually what happens is you jump to the next option here using wet hull panels. Let's take a look at what that looks like. If we just exclude this, add existing data. This is what I used, a coarse lid as I call it. And we'll plot. So really it's just using the default but with wet hull panels. So it's trying to synthesize a lid from the actual wetted hull elements along the waterline, and sometimes it works great. I find that it works no matter what, no matter how funky the geometry is. However, the problem is it doesn't always have the cleanest lid that comes out of it. So it does a good job of getting all the way up the front of the bow here, but then there's lots of gaps. It's kind of jagged, and then there's holes in the middle. There's these little holes in here, so you're not getting a ton of coverage. It's a little bit, inconsistent. But I mean, what you may find is you click and you generate this and you just move on. It's better than nothing for sure. So let's take a look at what those values look like. We will add existing data and the results with the course lid. And first thing I want to point out is the first consequence of the runtime. So previously we had about sort of 400, 500 seconds. You can see we've doubled the computation time to almost 1,000 seconds. Though it is a coarse mesh, so it's just something to keep in mind. Now let's plot the resulting values. So we've removed a bunch of the spikes, although we haven't got rid of everything, and it's certainly not perfect. And notably here in pitch, at the higher frequencies, we still kind of have a lot of noise. And again, we're seeing that condition number is quite high there, and kind of it's again giving me an indicator that there's some irregular frequencies here. So finally, let's look at the when we take our time and do some fine tuning on that. Exclude both of these, and we'll load the panel lid here. So I think these are the default parameters. Certainly, I think you could do even more to get more coverage. So we'll just put 0.99, 0.99, maybe even 0.01. Get it real close to the water line. Is that going to work? It worked. All right. So you can see here, just playing with it a little bit, we got even more coverage all the way up to here and all the way around. That's great. I believe I ran this with the default values, so let's take a look at what that looks like. We'll add the pre-computed values that I was working with. And so let's just view the output here. Let's close this old one. And view the output, scroll down to the bottom. So with even more coverage, like it's making a significant impact and is taking longer to compute the results. And that's just the way that the numerical mesh added by the lid sort of adds to the computational burden of resolving what's going on. That's not to say it's a bad thing. I think it's well worth it using the lid, but you just have to be mindful that it's gonna take longer to calculate the results. So, and here's the results with a really nice coverage with that lid. And this is really ideal in terms of having nice smooth curves for the wave radiation parameters through surge and all the other degrees of freedom. I mean, you can still see something happening in the condition numbers. That's not necessarily a bad thing. It's not necessarily a good thing. It's just it's a warning sign when you see them correlating with spikes in here. But we're not seeing any spikes, so this is really ideal data for using for seakeeping and maneuvering analysis or whatever other kind of motion analysis for whatever floating system that you're looking at. So yeah, the two main lessons are, don't rush, don't, take your time in seeing if you can craft a nicely fitting lid. It's worth it because you may only take 5 minutes to kind of adjust these numbers and just get it fitted in, get a lid that fits really well as much as you can in the interior area. If you spend a couple minutes, it's well worth it. It's well worth it because first off, you get way cleaner hydrodynamics data, but it's also something to spend time on because if you just rush through it and use the other options, you don't get as much coverage, you get a bit messy coverage. You spend a bunch of more extra time doing the calculations and it's not really as good as it could be, right? So of course, every project you've got, a timeline, you've got, limitations of what you can do. You have to use your own judgment, but it's something I wanted to highlight, and it's well worth taking your time to play with the lid parameters and fit it into the waterline area as much as you can. All right, thanks for watching.